our topic is about the use of artificial intelligence and 3D holograms for telemedicine, telecommunication, teleportation in outer space, space environment, and studying their impact on astronauts' central nervous system. And the authors of this project are Tomas Ducai, Anindita Mandal, myself, and Russomano. The outline proposal for such project consists of the following: rational and gap analysis, aim, objectives, hypothesis, research methodology, expected outcome, risk, benefits, cost-benefit analysis, future scope, and some limitations and risks. Regarding the rational and gap analysis, we consider that the application of multiphoton holographic optogenetic can repair the nervous system function or can also restore vision with the help of 3D model, and if it interferes with the coherent light waves of holography. Then the pain that is transmitted to the brain can also be monitored and controlled by holograms in such a way that it could fix the sparse code in the brain, and therefore research is needed in this particular area to better understand the methods or the ways that can improve the brain health and thus also increase performance of the astronauts. Our aim of this project is to use holograms for various purposes like 3D telecommunication, holoportation, and also use it also for health sector. The objective of this project that we want to achieve are the following: to increase the performance of crew members by improving their brain health and thus helping in their psychological condition, and also what we want to achieve is to evaluate the spatial frequency spectra of the 3D optical images or the quantum fluctuations in the quantum holographic teleportation, or studying the spatial temporal correlation function scheme. We think that it will be necessary in order to perform the 3D holographic teleportation. And also, we want to provide facilities for projecting patents organs in the space environment and the way to manipulate it by the use of infrared, and also ensuring complete sterilized intervention by helping in telemedicine. Now, we also want to test the spatial bandwidth of entanglement in the initial phases of the holographic teleportation processes regarding outer space environment and also Earth. For example, we want to use this technology for also live network transmission and also communication. Going further, our hypothesis consists in providing astronauts specific technology, holographic technology that can be used for telecommunication and also improve their brain health, and psychological conditions will also be monitored along with various other factors. So we are using such holographic technologies if there will be an increase in the efficiency of performance or results showing improved brain health of the crew members, then this will help us, or this will show actually the advantages or the benefits of using such holographic technologies for telecommunication and telemedicine, and also holoportation. Then we think that our research methodology is based on actually 3 situations, such as we want to achieve complete isolation, messages and calls, and holographic video calls. So we have these 3 situations, and we want to use artificial intelligence and holographic technology for virtual 3D meeting with the astronauts and their families. So we want to investigate the psychological symptoms by performance of behavior or social psychology tests. So we want to make more tests based on that. Then we want to study the changes or how the brain fluids are reorganized due to such holographic technology. Now we also have a selection of 3 groups of people. So we for the experiment part, we want to divide in group 1, where it will be a complete isolation, group 2, where it will allow only for sending mails and callings, not to forget about the essential technical characteristics of communication, such as time delay, and so on. And the group 3 will be provided with holographic technologies for connecting with their families. Now, going further, regarding the hologram construction and coordination, we want to implement 3D color holography, and also designing or implementing neural networks by using programs such as Python or TensorFlow for coding. Then we want to use 3D color displays by using optical chip combined with liquid crystals and nano structures. We want to use color holographic display system, and then implementing some sensors with fingerprint for the display, because we want these holograms to be tangible. And then we want to achieve 6G or use 6G network for transmitting this technology, and also adding neural codes with multi-photon holographic optogenetics. This will be for studying it will help for studying the brain health of the astronauts. So for this also we require holographic imaging and photosimulation of neural activity with high spatiotemporal resolution by using or by implementing special sensors. Moving forward, the expected outcome. Well, such technologies are thought to boost the brain health as compared with the flat screen video. Then they can convey the subtleties of non-verbal communication and provide a sense of presence along with immediacy. And actually, we want to enhance the quality of human interaction that can actually lead to better brain health. And the benefits of using this technology will improve the brain health of the astronauts, also their performance on their missions. Also, the patents organs can be projected if these holograms will be used in telemedicine, and their condition can be studied, and various parts of their body can be manipulated by the use of infrared, and also ensuring complete sterilized intervention. So we also want to take into consideration the application of multi-photon holographic optogenetic, and we consider that it can repair the nervous system function or restore vision with the help of implementing a 3D shoot model, and if it interferes with the coherent light waves of holography. So we consider that coherent light holography will help the multi-photon holographic optogenetics that can repair the sparse code of the nervous system. And also the pain transmitted to the brain can be monitored and controlled by holograms, such is actually very important because, as I mentioned before, this will be a way that it could fix the sparse code in the brain. Now, the thing is that the cost of this technology is pretty high for implementing the optical chip with nanomaterials. And therefore, our future scope regarding this, we want to achieve using quantum teleportation or quantum telecloning. How is going that be possible? By using optical images in order to create a perfect copy of the human. And we want to make it 3D at the same time we want to make it tangible. So that will be instantly, the image will be instantly transported to the spaceship from the Earth. This is how is going to work the transmission of the hologram. So our scope is to use this holographic technology or projection for any medical emergency and also for a 3D communication to improve space medicine by using advanced methods to visualize various alterations to the brain during the space flight and after landing to the moon or Mars and other planets, even to repair some function of the brain with this technology. Again, the thing about this technology is that there are some limitations, such as price. The price can be very high. As I said, if you want to use an optical a chip with nanosensors or nanotechnology. And then we need also ethical approval because there is a limited neuroscience legislation based on that. And also the brain rights are very limited. We have here a slide with a lot of references. And also we would like to acknowledge our professor Thais Russomano that she helped us in the process and she gave us a lot of guidance. And also we would like you, Professor Julio Resende, to thank you for organizing this Spice Habitat event and also for offering us this amazing opportunity to present our work.